Hello, it's the Cali Griot with an insomniac show for you tonight. And this is going to be about outer space. They've developed a telescope that's better than Hubble, way better than the Hubble. They said that they'll even be able to see where the Big Bang started. So I thought for tonight's Insomniac show, we would go over here with Jason. I think his name is Jason Johnson on NBC News. Everything here is for educational purposes. So stick around and see what you might learn tonight. All right. And I'll just say hi, y'all. So you came back to visit. I'm so glad you did. I really want to make this something special for everybody. So, by candlelight, once again, here we are. Okay? So, yeah, this is really exciting to me. My grandson's really into this. So, this is for you, hon.
Revolutionize our understanding of the universe, and it's set to launch on Christmas morning. You'll meet two of the scientists behind this landmark device just ahead. Stay close.
Joshua Johnson.
Our best present this Christmas might come from
My bad.
NASA, a telescope like the world has never seen, designed to look deeper into the universe than ever. It's as big as a tennis court, as heavy as a school bus. Remember the Hubble? Well, this one, the James Webb Space Telescope, is said to be 100 times more powerful, and it will orbit the sun. But the Hubble has taught us a lot in its 30 years of orbiting the Earth.
3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe. We'll be probing the time of the earliest history of the universe.
Almost a century later, the space telescope that bears Hubble's name gives us our most up-to-date estimate of the number of observable galaxies in the universe.
Ultimately, as is the case with all voyages of discovery, its greatest contribution will be the unexpected breakthrough that brings completely new knowledge.
Very cool. Joining us now are two scientists who had big roles in developing the new telescope. Dr. John Mather is senior project scientist on the project. He won the Nobel Prize in Physics in 2006. And Dr. Begonia Villa is a systems engineer at NASA's Goddard Space Flight Center. She is in French Guiana for the launch. Thank you both for making time for us. Welcome to you both. Glad to have you on the program. Dr. Mather, let me start with you and try to get at what we've learned from the Hubble and how we hope to advance it with the James Webb. As we mentioned, the Hubble was instrumental in our understanding of and discovery of dark matter in 2006. Talk about what dark matter is and how the James Webb might add to that research.
Sure. Dark matter is a substance that astronomers can detect the presence of, but we can never see. as far as we can tell, it's completely transparent, but it has gravity, and it's very important to us because from our story of the expanding universe, we believe it's the reason we are here. In other words, dark matter started moving soon after the beginning of the expansion of the universe, and it formed the objects that were going to lead to galaxies. So we are here in person today because dark matter started the process of forming galaxies a long time ago. So we will be looking at that and looking for the effects of that dark matter.
Dr. Vila, what about the James Webb Telescope itself? The Hubble needed some servicing around 1994, and it made a big impact in terms of the quality of the images that it sent back. What's the plan in terms of, you can see the difference, the before and then after the first repair mission. What's the preparation been like for preparing for potential repairs for the James Webb?
Well, Hubble is orbiting the Earth, so as you said, it was possible to do repairs. James Webb is going to be 1 million miles away, 4 times the distance of the moon, so we cannot repair it. So a lot of the effort on James Webb has been a very thorough test campaign on the ground to make sure that it is going to work as it should. And one advantage it has for Hubble is that the big mirror of James Webb, which is made of 18 smaller mirrors that we can fold to fit in the rocket, has actuators on the back. So we will not have the same problem that Hubble had. And if we did, we know how to correct it real time, sending commands from the ground.
Dr. Mather, another area in which the Hubble telescope advanced our understanding was the age of the universe. How does the James Webb factor into that? Is it kind of connected to what you were talking about with dark matter and understanding the forces that began to move after the beginnings of the formation of the universe, or is there more to it than that?
No, there's more to it than that. The Hubble was used to detect the fact that the universe is accelerating, expanding faster and faster every day. And we expect to measure that effect much better with the Webb telescope because we can see farther back in time and we can see the infrared light. It helps us see those special marker stars that are called supernovae that we use to measure distances. So we expect to get a better measurement of this, but it's gotten very interesting in the recent years because now we have more than one way to measure the expansion rate.
Those red
Getting the
dots
same
are my
answers
candles
every time.
reflecting.
So something's out there, something very mysterious.
That's not in the film.
Dr. Vila, oh, go ahead. I'm sorry, I thought I'd cut you off there. Sorry, but Dr. Vila, there's also something on the Hubble telescope, on the James Webb telescope. I don't know why I'm confusing these two. The Hubble is the old one. The James Webb is the new one. I know that, and there is something on the new telescope, the James Webb, that the Hubble did not have, and that is cryogenic and vacuum testing that didn't have here on Earth. Why were those important to add?
So James Webb is going to be in space, so we need to have it in vacuum. But James Webb is going to be looking at the universe with these new eyes and a different wavelength, which is the infrared, which you can think of kind of like heat. So to be able to detect the signal of the objects that are emitting that light, we need to be able to cool everything else, otherwise we wouldn't see it. And to do that, we have to go to these very cold temperatures. James Webb is going to be at 40 degrees Kelvin above absolute zero, minus 383 Fahrenheit. We do that by having a sun field, which is kind of like a big umbrella that we can open up so the instruments and the mirrors are in the shade and are very cold. So it was very important on the testing on the ground that we duplicated those conditions of cold and vacuum to demonstrate that everything will work on orbit as it should, and we have done that.
Dr. Mather, let me ask you about something that always comes up when it comes to doing space-based research, and that is the cost to taxpayers. According to the Government Accountability Office, which is sort of the investigative arm of Congress, the cost of the James Webb Telescope will be around $9.7 billion. The project's costs have nearly doubled over time. The launch date had been delayed by over 7 years. Obviously, this is highly sophisticated science, so it's got to be done right. You literally get one shot at putting this thing into space. Talk about the cost, the work hours, the time involved, and the benefit to the American people of doing this kind of space science, especially if some of the results of this science may not come back in my lifetime.
Oh my goodness. Well, I can tell you where all the time and money went is to make this incredibly difficult thing work. We had to invent 10 different new technologies to make this project work. We had to get the ways to make those mirrors. We had to figure out how to focus the telescope after launch. We had to figure out how to make that gigantic sun shield that's as big as a tennis court. We had to get better infrared detectors than we ever had before. So we had to invent things before we could even finish the design. Then, of course, after you got the design, you have to prove that it works, and it takes just forever to do the proper kind of test, especially if it doesn't work right the very first time, and things hardly ever do. So it takes about 10,000 people for this period of time, over 20 years, to do this project. So that's what it takes to do this, and as far as we know, there is no other way to get this kind of information. We need a big telescope to be able to see far back in time, far out in space, to see inside those dust clouds where new stars are being born today, and even to see planets as they go in front of their little stars out there, and to begin to find out are there planets that are a little bit like Earth out there, and we hope so. So
Right.
the benefits to the public, well, huge.
I love it when people
There's
complain
only
about
one
the
way to get
benefits of
this.
space science. Yeah, I love it when people complain about the benefits of space science and they do it on a device that requires GPS, that requires satellites that depended on space science to fling them up into orbit. So there's that. Before I have to let you two go, Dr. Vila, is there anything in particular that you're looking forward to learning from this telescope? Any projects you'll be involved with, or just any big questions that you would like this telescope to help answer?
I think it has a very lofty goal on all science, looking at those first galaxies and stars that were formed, and looking for the atmosphere around those exoplanets. And about 6 months after launch, we will have an example of what all the instruments on James Webb are able to do. And I think all the science goals are very worthwhile. So I think on my side, I'm looking forward to all of them, seeing all those images and spectra, and see what's out there in this new way of looking at the universe around us.
And Dr. Mather, briefly before we go, anything in particular else? Anything else that you're looking forward to learning?
Well, I think there are going to be some surprises out there. I don't know what there be, or I would be proposing to look for them. But we've got a crowd of thousands of astronomers that know what they're going to look at, and we hope they find something that nobody knew about. I think there'll be something.
That is a great answer. I want to know the thing that I don't even know to ask about. That is a fabulous answer, and I am very, very much looking forward to seeing what this telescope teaches us about who we are in the universe. Dr. John Mather and Dr. Begonia Vila, we appreciate you both making time for us tonight. Thank you very much, and good luck with the launch on Saturday. Up next.
Now, those are the kind of stories I love. I love science and, math. I'm not good at math, but just the whole idea that they would be able to go back in time. The whole time is relevant, time and space and all that good jazz, I'm just really glad you came back to visit at the Cali Griot. You came back to the spot. So hopefully you got to learn something interesting. And for my grandkids that are out there, I love you. And I hope you got to learn something interesting tonight and visiting with your yaya. All right? So I just want to say, comment, subscribe, ask questions, go for it. And you tell me what type of scientist you want to be when you grow up. I know we have one working on biology again and biochemistry. Good job. You guys keep it up because you're going to be the leaders. Cali Griot, good night.